Hey, welcome back. I'm struggling with this recording, but I'm going to get it done. So I've already written out my notes twice and started recording like 7 times, but my computer keeps freezing, so we're going to try to get through this. I'm not going to rewrite my notes again. So this is available on that document in a little blue teal circle with a notebook in it. You can access my notes there in case you want to see the whole page at once. So we're doing transformations, which means we're taking something and we're changing it. So we're either shifting it around, we're flipping it over or this way, or we're stretching it. Now we only stretch it from the top and the bottom, or compress it from the top and the bottom. There is technically one where we pull it from the sides or push it from the sides, but they're almost the same thing. And so we're not going to worry about that until we get to the one chapter that requires it, which is not until second term. So don't worry about this box. Don't cross it out, but don't worry about it. So the first thing we do is we worry about stretches and shrinks, or compressions. It's the same word. And we'll know it's a stretch or a shrink if there's a number in front of the function. The function can be a squared, the function can be absolute values, the function can be a square root, the function just can be f. Those are functions. And since there's a number in front, all of these are vertical shrinks or vertical compressions of a half. If it was a big number bigger than 1, it would be a vertical stretch. Next thing we worry about is reflections. If the negative's inside with the x value, it flips over the y-axis. So it goes from here to here. If the negative's outside, it flips over the x-axis, which means the graph goes from here to here. I can't show you, but it goes down. The third thing we worry about is moving it. So in moving, this is going to be so confusing, and it's okay, and I still appreciate that you're trying. It says x minus h, which means that it's opposites. If h is a negative, then it's actually going to the right. So it says x minus 4, we're going to the right by 4. If it says x plus 4, we go to the left by 4. It's backwards. So just remember that this one box is backwards. And if it helps you later, this one will be too, but we're not going to worry about it yet. So this one's the one that's backwards in your head, and that's okay. Opposites. Half of Algebra 2 is figuring out when it's opposite and when it's the same. So we already know that 30% is transformations. Oh, we don't know that. That was another recording. 30% of Algebra 2 is transformations, which means that 1, figure it out now, or else you'll be confused forever. Or 2, we're going to keep repeating it, so you'll get it eventually. So it's okay. The last thing we can do is if there's a plus number on the very outside, that's up, and if it's minus, it's down. So if it said a function plus 7, it'd be up 7, minus 7 would be down 7. So we stretch it, we flip it, we move it around. We're going to start each of those separately first, and then we're going to get to them kind of combined. So I just did one example that are all the same. All of these have a reflection over the x-axis because they're all negatives in front. They all have a vertical compression of a half because of all of the halves in front. They're all right 4 because of all the minus 4s, and they're all up 7 because of the plus 7s. Now, the fact that this one is squared means it's a U shape that's been reflected, compressed, right, and up. This one with the absolute values means it's a V shape, which means the V shape's been moved, flipped over, compressed. The square root means it's kind of like a whoosh without my sleeve. Whoosh. That's been moved. And then this function means it's any function. For example, I had this Harry Potter scar down here. That's my original function. And I wanted to graph g of x, which was 2 times f of x plus 3. The 2 in front means it's a vertical stretch of 2. And the 3 on the inside means I'm going to the left by 3 because it's backwards. So I'm going to do the vertical stretch first, because it's the first thing I do. I'm going to double every height. So what I did was I took this point, which is 3 high, and I went up to 6. So this point, instead of being 3 high, is 6 high now. This point, instead of being 1 high, is 2 high. This point, instead of being 2 high, is 4 high. And this point, instead of being down 1, is down 2. Doubles, times 2. And then I moved all of those points to the left by 3. So this point went left 3, this point went left 3, This point went left 3, and this point went left 3. Now, the general feeling of the shape is still there, but because of the stretch, it's not exactly perfect. And I just want to really quick tell you that if you have to flip it over, if I want to flip it over the x-axis, this point, instead of being up 1, would be down 1. And this point, instead of being down 1, would be up 1. But if I want to flip it over the y-axis, I look at how far away it is from the y-axis. This is 1 over, it'll be 1 back. This one's 2 back, it'll be 2 over. So I just switch them. And it's kind of like a mirror, it'll be flipped over. So I hope that helps. Again, this is on that lesson document in a little teal circle that has the notebook in it, and it says notes by it. So that way you can take these on your own and then maybe watch this later, or vice versa, because you've already finished watching this now. I really hope that helped. If that did not help, please come tell me. Email me, write it in the FAQ, give me some time during my office hours. I will help you do everything you need to do. I've got your back, I'm here for you. You put in the work, I'll put in the work. You're worth it, and I hope that you know that. And if you don't know it, I'll believe in you until you do. So I'll see you during our class time, and I'll see you during my office hours, hopefully. And I hope you have a great day.